Okay, so question number 7. Draw the Lewis structure of sulfur tetrafluoride showing all the lone pairs. Identify the molecular geometry. What is the hybridization? What are the ideal bond angles of this geometry? And is an SF4 molecule polar or nonpolar? Okay, so let's start off by writing the Lewis structure, since this will help us answer all of the following questions. So when writing out the Lewis structure, we first need to calculate the total number of valence electrons in this molecule. So in the case of sulfur, sulfur has 6 valence electrons, and fluorine has 7. And since there are 7 fluorine atoms in this molecule, there are 4 fluorine atoms in this molecule, we multiply this by 4, and we get a total number of 34 valence electrons. So now let's try to sketch out the skeletal structure of SF4. So sulfur will be our central atom, since it is the least electronegative. And then I'm just going to draw 4 single bonds to the fluorines. And I'll also draw in all of their lone pairs. Okay. So if we count out how many electrons I have so far, we have 2 electrons that are participating in the bond, and we have 4 bonds. And we also have 6 non-bonding electrons on our fluorine atoms. So we only have 32 out of the 34 electrons drawn. So for the remaining 2, I'm just going to add them as a lone pair on the central sulfur group. So this gives us our final Lewis structure. So now let's try to analyze this Lewis structure to find out its molecular geometry, hybridization, and the bond angles. So the central sulfur atom contains 1 lone pair and 4 bonded atoms. So now we can use a helpful VSEPR chart to help us answer all the following questions. Okay, so this is a VSEPR theory table, and you can see that when you have 1 lone pair and 4 bonded atoms, this is on the next page. Yep, so right here. When we have 1 lone pair, 4 bonded atoms, we have a seesaw molecular shape. And we also have a trigonal bipyramid electron geometry. And this chart also can show us the hybridization. So it is sp3d hybridized, And another way we can find out its hybridization is by counting the number of charge clouds. So charge clouds can be the lone pair and also the bonded atoms. So we count out 5. And when you have 5 charge clouds, this is sp3 dehybridized. And finally, the bond angles are 90 degrees and 120. Okay, so that answers the first couple parts of the questions. And is the SF4 molecule polar or nonpolar? Okay, so to determine whether or not a bond is polar, we need to find out the electronegativity values of the atoms that are involved. So let's find out the electronegativity difference between a sulfur and a fluorine bond. So fluorine has an electronegativity value of 4, and the sulfur has an electronegativity value of 2.5. So this tells us that the difference in electronegativity is 1.5. So therefore, we can say that the bond is polar, and this is because our electronegativity value is greater than 0.4, but it's less than 1.7. That's another way we can tell if a bond is polar or nonpolar. And we can also show these as dipole moments on our molecule. So since fluorine is much more electronegative than the sulfur, we can show these dipole moments like that. But due to the lone pair, then these dipole moments don't cancel each other out. So we'll actually have a net dipole moment kind of going towards all of the fluorines, like that. Oops. So we can say that we have a non-zero dipole moment. And this is because of the structure of our molecule, which is trigonal bipyramid. So this tells us that sulfur tetrafluoride is a polar molecule as well. Okay, so not only are the sulfur-fluorine bonds polar, but also because they don't cancel each other out, we have ourselves a polar molecule. Okay, so now let's see what the junior tutor said. Step 1 is to list the elements, their valence electrons, and determine the total valence electrons. If a charge is present, then you would add the value of the charge to the total valence electrons when it's negative, or you would subtract it if it's positive. So we didn't have a charge on our compound, so we didn't need to do that part. And they found 34 valence electrons. They drew out the skeletal shape and showed all the lone pairs and got the correct Lewis structure. Okay, so now they determined the steric numbers. This is the same thing as adding the number of lone pairs with the number of bonded atoms, and they got 5. And when you have a steric number of 5, it is sp3d hybridized. The electron pair geometry is trigonal bipyramid, and because there was one lone pair, we have a seesaw molecular geometry. So I think they summarized it down here. seesaw. And since this molecule is asymmetric, it is polar as supported by the net dipole shown below. So they also showed how all the fluorines kind of are more electronegative, and the lone pair causes them not to cancel each other out. For this molecule, there are 2 bond angles present. For the equatorial fluorine-sulfur-fluorine bond, it's 120. Okay, so they showed that here. And for the axial equatorial fluorine-sulfur-fluorine, the bond angle is 90 degrees. So therefore, it has molecular geometry like a seesaw. The sulfur is sp3 dehybridized. 2 bond angles are 120 and 90 degrees. And since it's asymmetric, it has a net dipole, and thus it is a polar molecule. Yep, so this solution is correct.